информационных моментов. Wi-Fi вы можете найти на своей регистрации. Если у кого-то будут какие-то проблемы с подключением, тоже можете обратиться к ребятам, они помогут вам совсем. Примерно через час будет небольшой кофе-брейк. Прямо здесь, никуда не надо идти. Вот, и без лишних слов я представляю дома Sydney Kerckhove. Let's switch to English and start our workshop.
Yes, please. Thank you. Can everyone hear me well? Is it too loud?
No, it's okay.
Is this better? Okay, well, we'll see. So the first part of the talk is going to be a lot of talking, and then afterwards we'll start coding together. This is really loud. Yeah, that should be better. So to follow along with the code that we're going to be writing, you will need to have something to build Haskell. I recommend Stack because I can't help with anything else. If you're using Windows, you need to do it within the Windows subsystem for Linux, because while Stack works on Windows, the library that we're going to be using to write a TUI does not. So while I'm talking, the first half, or first part, get that working so that you can follow along in the second part. It's supposed to be really interactive. So we're going to build something together, and I'm going to show you what we're going to build in a moment. And the idea is that you'll follow along. I built this little starting point, which is at the link there. So you should clone that, the repository, and make sure that stack install within there works. And then at appropriate points in the workshop, I will do a commit while I'm typing, push it, and then if you couldn't follow along until that point, you can just pull again and follow along again. All right? So make sure you have this repository and then you have something to build it with. Now I'm going to show you what we're going to be building. So this is just going to be a little text editor in Haskell using Brick. Now I need to pass in. So this is what it's going to look like. It's just standard text editor. You can type buttons to add text, and you can press arrow keys to move around, break up text, etc. All right, so that's the idea. Now, the question is, why would you do this? I recommend using TUIs to start learning Haskell with, because it's real world. You can actually build something useful with it. You can also write a command line interface, but this is going to give you much more of an immediate feedback, which you're going to enjoy during learning as well. I like TUIs in general because you don't press any buttons on your mouse, which is a lot slower than using the keyboard. Instead, you can just press buttons on your keyboard and then have things happen. It also looks also with an L. Right. So now that you know what we're going to be building, I have to explain a bit of the background of how the library is going to work. But first, I need to know a bit about your Haskell level so that I can know how to phrase things. So, who here has never written Haskell before? Alright, so 4, 5, 6, okay, that's a bit more than I expected, but that's good. Then you can just yell at me and go like, hey, what does that mean? And then we'll explain it again. I don't mind explaining anything or anything twice, but you have to tell me because sometimes I just don't know what's unclear, okay? So if anything is unclear, just shout at me and then I'll stop and explain it. But don't wait for me to explain something if you don't understand, okay? Just tell me. So about 6 people who've never written Haskell before. Of the other people, can you raise your hand if you've ever written something within I/O? All right, that's most of the others. Okay, good. So we won't use much I/O today, which is another reason why TUIs are great to learn with. But again, if anything is unclear, just tell me. Then, in order to write a TUI, there is this architecture that the library that we're going to be using, Brick, is using. It's a bit like the Elm architecture, but it's in Brick. We call it the Brick architecture because it also has a few diagrammatic differences. So at some starting point when you enter the TUI, you will start with a certain state of your TUI. This state is then drawn purely to the screen in a nice image fashion. Then the control is handed over to Brick, who then waits for some event. An event can be a button press, resizing your screen, it can be clicking your mouse, it can be scrolling, or it can be any other event that you can send in from the outside. And then once this event comes in, Brick gives you back the control. You do something with the event in order to change the state that you have internally in your TUI, and then the state is changed, and then the new state is drawn again, and everything starts over until you somehow exit the program by returning a different kind of state, which is just the let's stop this thing now state. Is that clear? Cool. So that's the brick architecture. In the meantime, if anyone is still having trouble with installing the prerequisites, ask around, because I just helped some people and they will probably know what to do. So I'm going to unpack a bit what a brick apps looks like. So there are 3 type parameters. Looks scary, it's not scary. If you've never written any Haskell, do you read Haskell? A little bit? Alright, so if anything is unclear, just tell me. I used to teach Haskell to beginners, but I'm not used to doing that in workshops. So I can explain things, I think, but you still have to ask. So there are 3 type parameters to a brick app. The first type parameter is the state that you're going to be managing within your application. The second is the type of custom events. We won't use this, so we just leave it as a parameter. The third is the name of the resources. We also will almost not use this, so I'm going to forget about it for now. Then this application has 3 important parts. There are 2 more parts which are not so important, and I've already filled them in the template. There's the drawing function, app_draw, which takes your state and turns it into a list of layers of the image on top of each other. We'll only use 1 layer, so this is going to be a singleton list. Then there's the app_handle event function that you have to fill in, which takes the state, the brick event that brick will give you, and you will have to construct the next state while maybe doing something first. And then there's the attribute map, which is something like CSS. So you can give everything fancy colors. This presentation is in the repository, by the way. It's just a markdown file, so if you want to have a look at this or have a look at the documentation, you can just look there as well. Next up, I have to explain to you a little bit about what kind of state we'll be managing. And in any other language, you might use for your text editor just a piece of text and an index within the piece of text to mean that's where we're looking in our editor, right? Now, there's no such thing as pointing at something in Haskell per se. This kind of pointer is not easy to make safe. So instead of using such a more mutable approach, we're going to use a more functional approach. And this is called a cursor. So a cursor for a thing is something that contains both the entire thing somehow and also where you're looking within that. So for example, a list cursor, which is something that represents where you're looking between 2 elements, you can represent it as 2 stacks, where the left stack is the elements to the left of your cursor and the right stack is the elements to the right of your cursor, right? So if you have 1 element on the left and 5 to the right, that means you're in between the first and the second element of a 6-element list, right? Or a non-empty list cursor, that's where you're looking at an element. We just have the current element between the 2 stacks. Does that make sense? Right? And so more abstract, there are also tree cursors, so that you can look within a tree. We don't need this at the moment, but just so you know that this exists as well. And then the ones that we're going to be using is called a text field cursor. So that is both the entire text field and also where you're looking within the text field. And then there are a few important functions. These are all available in the documentation. The documentation will be on the last slide that I'm going to show you while working. There's a way to make a text field from a text, which just starts you off at the beginning. And then there's the rebuild text field cursor function, which turns it back into text so that you can show it, for example. And then there are some functions to manipulate this cursor to just move around, for example. That's with the next character and the previous character, for example. And then this is wrapped in a maybe so that you can fail. For example, you can't go any more to the right if you're on the last line at the end. And then there are functions such as remove, which can manipulate the contents. In this case, it will remove the previous element where you're looking. So the backspace key is what this is for. This will return maybe because there may not be anything to remove to the left, and it will also return a delete or update, which is just another way of saying maybe, because it could be that you would like your text cursor to be removed entirely if there's no content and you press backspace. Is this clear? This is just Haskell 2010.
Is the delete or update is event or?
It's in the package, so that's taken care of. You'll see more about that later. It's really just a fancy maybe. But having maybe is very confusing. So here are all the relevant links. So So there's a starting point, which is not the one we're going to be using today. It's just a starting point for any TUI. So if you ever want to write another TUI and you need TUI and you don't know where to start, you can go there. This is all available in the repository, so you can just click on the links there. So if you want to write your own TUI at some point, start there, and a lot of it will be filled in already, and you just have some pieces to fill in. Then if you want to follow along with what we're doing now, I recommend it, that's what we're here for. Then the second link is where you clone, and you run stack install within there. Once it finishes building, it will also download the compiler for you. Once it finishes building, we can go ahead and start. Then there are links to the cursor package, which contains all the cursors I talked about, and also the textile cursor that we're going to be using. There's the brick package, which contains the library for drawing the trees. Then there's cursor brick, which is used to show cursors in the brick application. We're also going to be using that most likely. Then there are specific links for a textile cursor and drawing a textile cursor. So I'm going to go over all of this with you in a moment, but here are all the links together so you can follow along. Right. This is the end of the talking part. Is there anything unclear until now? Because then now is the time to ask me. Is it too fast? Is it too slow? Am I annoying? All good. Okay. Good. So let's have a look at the actual code then. Yay for my commit messages. So, within the text editor subdirectory of this repository, we will look at the source in tui.hs. And a lot of this has already been filled in, such that you only have to fill in the missing pieces. Now, if you've not written any Haskell before and you can read this, that's enough. The rest will come along. The only thing you'll have trouble with is the syntax. The rest is relatively simple. So I'm going to go over this example for a moment, and then you should be able to figure out where to fill in the pieces that we're going to be working with. So the first function you see is the starting point of your application. The first thing we do is we build the initial state when we run brick on it with the default main, and then we get some end state and I print it just because I want to do something with it, but you don't need to. Then the first thing to fill in is the TUI state, which is the state that we're going to be managing. So that will probably contain just the text field cursor. Then there is the resource name, which you can just ignore, but it needs to be there for ambiguity reasons. And then TUI app is the actual application that we're going to be writing. So the TUI state is the state parameter filled in. E is the event parameter, which we won't be using, so it's just a parameter. And then there's the resource name, which you can mostly ignore. Then the app draw, handle, event, and attribute are all filled in for you. You can mostly ignore this part of the code as well. Then come the pieces that we have to fill in. There's build initial state, which is where we're going to read in a file and put it into the state of the application. And there's draw TUI. Yes?
Excuse me, why did you prefer to use pure instead of return?
Because it's the same. Because it's the same.
It is the same, but it looks a little bit untraditional.
Oh. I didn't mind.
Okay.
I hope that they one day remove return, and in that case, my code will still compile.
Are you sure they will remove return, not pure?
I hope so.
Okay. It would be better to remove both and rename to RUP, for example.
But then all my code breaks. So maybe. Anyway, so. Yes, we're going to build the TUI state over there. Then in the next function, we're going to draw it to the screen. This is currently an empty list, which is why the app crashes when you run it right now. And then there's handle TUI event, which is where we're going to implement the event handling. Most of the annoying parts have been taken care of. What we're going to do now is write the fun parts. Okay? So fire up your text editor, and let's get going. Okay, so let's fill in the missing pieces. How much time do I have? I've been talking for 15 minutes. Okay, so we have a bit more time than we'll probably need. That's intentional, so that we can do this relatively slowly so that everyone is with us, okay? So now, to start off, we're going to implement first of all, make a feedback loop. So I'm going to open up the same directory in my separate terminal and start a feedback loop, and my feedback loop will be stack install file watch, and actually I also want to add fast. Well, so now this is being built constantly, which means whenever I make a change and it doesn't type check, for example, I will see the errors on the left and I can fix them immediately. Running your feedback loop in a place where you can see it while you're coding is one of the most important things in coding, I think. So I'm just going to show you how to do it. Good. So you've got the feedback loop, you've got the code. Everyone's along with me? Does everyone have the appropriate tools? Okay, so first step is to change the TUI state to what we want it to be. Then we'll get a whole bunch of compile errors, and when we fix them, hopefully the thing works. Okay? So, inside the TUI state, we're going to add the text field cursor. And this doesn't compile because it's not there. It's in cursor.text field. And now we're going to get compile errors that we get to fix. For the people who haven't written Haskell yet, if you just tell me immediately if you don't understand something, don't be scared about asking. I won't explain things unless you ask, because otherwise it's going to be slightly patronizing if everyone does understand what I'm doing. So now we get a compile error here, because now TUI state is not a value but a function, which means we have to fill in the cursor there somehow. Actually, I can use this. If I can find the right button. Where's the underscore? You would think I could type by now. Okay. I'm sorry?
You can copy and paste it from somewhere.
Yes, you're right, but where is there? Oh, there is someone. There is one. It's not honest, yeah, that's true. All right, so for the people who haven't written much Haskell, this just means I don't know yet, and the compiler will fail to compile something like this because you still have to fill it in. So we're going to have to fill in the text field cursor there somehow. Let's call it TFC. And to make a text field cursor, we use the function make text field cursor, and we have to pass in a text. Now, this text is going to come from, I assume, the file that we're going to be editing, right? So, to get that file, we're going to be using text.read file, which you shouldn't be using, but in this case it's fine. Example.txt. We can talk about how to pass in arguments later. Now this won't compile because the read file is not important, so I need to import data.text.io as t. And then I need to make sure the text is in the dependencies. Alright, that seems to be working. Now, what's going to happen when I run this? It is probably going to crash for multiple reasons. So the first reason is that the file isn't there, so we can't read the file. Right? So one way to do this is to say, if the file exists, then read it, otherwise don't read it. The problem with that is, if there is another reason why the file cannot be read, you still get the error. So instead, I like to use a more parsing approach by using a function that forgives absence, as we say. So for that, I will need two packages, path and path.io. And then I need to first make a path with resolve file. This just makes an opaque value p, which represents the path there, and also takes care of symlinks, etc. for you. Then to read that file, we have to turn that back into a string, because read file doesn't use paths, but uses strings. So we use from apps file.
Calling your variables like p and t.
because I have 2 hours to write a text editor. You can call them path if you'd like, but using the names of your variables to denote their type isn't always a great idea. So actually I should call it contents instead of text. Good, so now we have the same problem still. We are using a better path type, but it's still going to crash on an empty file. So there's this function called forGivingAbsence, which takes any IO action and will return maybe the results depending on whether this IO action through an does not exist exception. Okay, so now we won't get contents, but maybe contents. And then if there are no contents, then we're going to just have an empty text. Okay, so I will need data.maybe. And now I have to wait for the compiler to finish to tell me if I did anything wrong. Is anyone following along? Yes, okay. Is there anything unclear in this part? No, makes sense, right? Oh, it's too fast, okay. Well, I'll take this time to tell you a little bit about my experience here. Coworker, yes?
There is a function resolve file prime. I assume there is another one without prime.
Yes.
What's the difference?
So resolve file prime looks in your current directory. Resolve file has 2 arguments. Without the prime has 2 arguments. The first one is the directory in which you're looking.
Right.
So this is the same as that.
Absolutely.
Make sense? This is handy, depending on what you're using the path for. I've really prevented a lot of bugs just by using this library because it forces you to think about whether a path is relative or not, whether it points to a file or a directory. And in this case, I'm just using it for the forGivingAbsence part, but I find it really useful. Now, why is it taking so long to compile this?
Could you tell more about forGivingAbsence? You mentioned the exception, but
Yes.
what must be its argument?
Oh, I will also need to import that, but I'll do it in a moment when I can get the error. So there is forGivingAbsence. Is this readable?
Yes.
Okay, so there's forGivingAbsence, which takes an IO action and just returns the same IO action, except it can fail. It doesn't fail, it just catches the exception to return nothing. So this way you can forgive the absence of the file. You can also ignore the absence of something, but then you just can't get the result of it. So for example, if you only want to write to a file if its parent exists, then you use ignoring absence, for example. All right, so now we got some type errors, that's nice. Right, so the first one we will need is path. The second one is called path.io. Path contains the file path, the path types, path, and also the parsing mechanisms, and path.io contains all the functions that use them. Okay, so now we've got build initial state sort of ready. To show that it's working, I'm going to make a very simple way to show the state by using str, which turns a string into a widget. A widget is what Brick uses to define what it's going to show, and I'm going to just show the state as the way to show the content of the state to the screen. So then if I compile it again and run local bin text editor, I should see something really annoying. You see? So it doesn't even fit on the screen. So I could use string wrap, and that will wrap the string around the screen if necessary. Like so. Now you can see the actual contents of the state. This is still a bit annoying, so I'm going to use text.show.pretty, which is going to show this in a nicer way, but it's in a package called pretty show. And then instead of using show, I use pp show. All right, in the meantime, any other questions?
Did we already introduce the text field cursor tag? Just please. Or we imported it?
Sorry, could you repeat that?
My event loop shows me text field cursor is missing. Tag text field cursor.
Did you have this line?
Yeah, I have this line, but maybe I don't have it.
Oh, you mean this function is missing?
No, it's a type text field cursor.
Yes.
This type.
Ah, yes. So you need to make sure you import it, like so.
I just missed this.
Okay. So this is what the text field cursor looks like on the inside, just so you know. So now we have an uninteractive TUI, which just shows you an empty file. What a text field cursor contains is a non-empty cursor, so of lines, which means that you can go up and down in the text field by going left and right in the non-empty text cursor, non-empty list cursor. And the current element of the non-empty list cursor of lines contains a text cursor, which is just a single line of text. So we have a non-empty list cursor of lines, which contains one text cursor, which is the current line that we're looking at. The other lines are represented as text and not as cursors. And here the text is empty, so we see no characters to the left and no characters to the right of the current position where you're looking. Because when you're using a text editor, you're looking at a line but between characters. All right, so we have a, yes?
Which library do we need for text show bracing? Because it can find it.
For what?
Text show bracing.
Ah, this one. It's called Pretty Show.
Pretty show.
So to make sure that everyone can still follow along, I'm going to commit this, so you can just pull, and then you don't have to do all the typing yourself. Now, if you want to follow along again, you just pull and you go along. Okay, so we've got a non-interactive TUI that can show us the internal state of an empty file. Next step is to show it in a nice way. So we want to actually see the text editor that we're using. But if I just show you how to do that, then the result will be an empty screen, which is also not so nice to look at. So first of all, let me put something in the file so we have an example of, so we have something to look at. So if I open this text file, like so, and I run that now, something is wrong. Oh, because I'm running it from somewhere else. There we go. So now we have a text cursor with some actual contents. So you can see we're looking at the very first line at the very left. So all the text is to the right on that line, and the next line contains just this. Because there is a new line at the end of the file, there is also an empty string on the last line. Okay? So now if we have some good way of showing this text field cursor, then we should see it as soon as we write that piece. So there is a library to help you with rendering cursors. It's called Cursor Brick. And there is Cursor Brick text field, which lets you show a nice cursor. Okay? There are two ways of doing this. There's either a way to show the text field as is, like when it's not selected, or a way to show a text field with this blinky box. This thing. That here. That's what the one we will want to use, because our text field will always be selected. But for example, if you use another program which has multiple text fields, so for example here is the first, and now it has a blinky box, But now, if I'm looking somewhere else, the blinky box is down here, and this is still a cursor, but it's not selected, so it shouldn't have this box. Okay? So we're going to want to use this function. Like so. And now there is an argument missing, because the first argument to this function is the n, as in the resource name. The reason we need that is because Brick needs to have an overview of where it has to have an overview of all the resources that it's managing, and one of the things that it's managing as a resource is, for example, the blinky box. So we're going to have to give the blinky box a name of type n, but we're going to have only one of these resources, so I'm just going to call it resource name. If you don't understand that piece, you don't really need to. Then we need to import this piece, and also this piece, and it's already in the dependencies, so that just works. Right, now if we run our text editor again, then we have a non-interactive way of showing a file, right? And there is a blinky box, but we can't move it around because we have no way of moving the cursor yet at all. So this is what you should see if you're following along. For the people who are moving along, is this what you see, or do you have any trouble somewhere? Down.
I suppose the community is just down. Does it have where to show library inside YAML file?
Okay, so in that case, you need this here.
Okay.
Makes sense? Any other trouble like that? All good? Okay. So at this point, you should see something like that. Okay? And so the next piece is just going to be how do we move around the blinky box and how do we add some characters in between. Make sense? Okay. So I'm going to make a commit again, so you can follow along if you didn't catch that part. Showing a text field cursor. So really the quote-unquote difficult parts have been taken care of already. It's because you didn't have to write this file, for example. If you want to know what that looks like, by the way, you could write it yourself, and I recommend you do if you're interested in this kind of stuff. But essentially all we're doing is taking apart the text field, the cursor's inside, putting the text in the right places. Then VBox is a vertical box, which just puts a list of widgets in a vertical fashion above each other. And then there is also the blinky box part, which is in here, where you just have to say, tell Brick to show the blinky box with a certain location. Yes?
By what way returns an array? What is the order of Brick will print widgets?
It's layers on top of each other. So the first, I think so. The only places where I ever use that functionality is if I want to have for example, a help screen that shows up if you press question mark and then disappears again. Yeah, exactly. I don't use it much because now, for example, I had a help screen for SMOS, that you can get to with the question mark, but it takes up the entire screen. So, okay. Now, this is the fun part. What do we do with the events? So Brick is, if I understand correctly, it's built on top of something called VTY. And if I do understand correctly, it doesn't have anything to do with n curses. And VTY is the more primitive, lower level kind of thing, and then Brick is more declarative on top of that. But the reason why I'm telling you this is because the events are still called VTY event. So there are multiple events you can get for Brick. One of them is the VTY event, which means anything from below, like pressing buttons. And then the other ones are, for example, custom events, where you can send events to the Brick application, like, for example, this is the progress of the download you were just doing, and then show it in a certain way. So, for example, you can have a separate thread listen for instructions to download something, have it send over the progress, and then show a nice progress bar. Okay? So, inside a VTY event, one of the kinds of VTY event is called a key event, which means a key was pressed. And this contains information about how it was pressed. So you can have, for example, a character or enter or whatever, and then a list of modifiers like shift, control, meta, or alt. And somehow meta and alt are different, although I don't really know how that works. Yeah. And sometimes also on some machines only meta means alt, and sometimes alt means meta, but there is no meta button, and then it's confusing. So in this case, the only thing we have is that when you press Q, the application stops. Okay. So now, for example, I would like to have a way to insert a character that we type. So in that case, Q is going to be annoying to stop. So instead of pressing Q to stop, I'm going to say key escape, I think like that. So you can press escape to stop the editor, otherwise you could never type a Q. Now I can, no, Q doesn't work anymore, but escape does. Yes, voila. So now when I receive a key event with a character without modifiers, then I'm going to want to continue. And now here I want to write the next state. Okay. All the organizers are gone. There is no cough button, is there? Okay. So we're going to have to make this new S, and the S is going to be a new true state with a new text field cursor. Now, to make the new text field cursor, we need to somehow add in the character that we have, the C, and for that we go and look at the documentation of the cursor library. And there is cursor.text field. Now there are a whole bunch of functions in here. They are fairly self-explanatory, but I neglected to add any documentation. So here, this is the one we want. So there is insert character, which means put a character where you're looking and then move to the right. And there is append char, which means put a character where you're looking and go to the left. If you use this one, everything you type will be backwards, which is a great bug to figure out. So this is what we're going to be using. It takes the character that you're going to be inserting, a maybe text field cursor. Why does it take a maybe? So you can create one from nothing if you don't have one yet. In this case, we already have one because we start with an empty file always, but you don't have to. So to insert the character, then we need the character, and then the cursor itself. So now we have a maybe text field cursor. Why do we have a maybe? Because this could fail. There are situations in which you can't add a character anymore. In that case, you want to return maybe. The reason why this can fail, because you might think, well, you cannot just always add the character, because there are characters in Haskell which aren't actual characters. There is something called a UTF-16 surrogate code point character, which is not allowed in actual text, but it does exist in Haskell as a character, because a Haskell character is just a 32-bit integer for some reason. So this returns a maybe. Now, what do we do if it is actually a maybe? Then we just don't do anything. The way you do that is you write from maybe TFC, and this needs to be wrapped in a just. Is that clear? Okay, so now we should have an editor where you can add some text, but you still can't move around, so you can only add stuff. So hello. But if I do space, that works. But if I press the buttons, the arrow buttons, nothing happens. Okay? And I also can remove what I just wrote. And if I close this now, the file is also not saved because we haven't implemented saving. Okay. Any questions until now? Because now I'm going to do the moving around part. Is there anyone who's considerably bored? No? Okay, that's good. So when do you want to move around? For example, I want to be able to move around with the left arrow button to go to the left. So K left. And now we want to do this whole spiel again, except a different function in the middle here. So select previous character. And this can fail because you could be at the very start of your file. So actually, we're going to have to implement both of these in order to see whether they work, because you start at the beginning of the file. So this can fail. In that case, we just keep the original text field cursor. Now I'm also going to implement write, some people are already really annoyed that I'm duplicating all this code. Who's that? I see someone like, yeah, I am. So we can deduplicate some of this stuff, but first I want to show you what the result looks like. So now I can press left and right, and the box will move. Okay? I can also add characters in the middle here, but I still can't delete anything, and I can't go up or down. If I press enter, nothing happens because enter is not considered a character. So let's deduplicate some code first, and then I'm going to push everything so you can follow along again. So a lot of these functions are of this form. So it's text field to maybe text field. Okay? So let's assume that there is such a function. And if I pass in that function, I just wanted to do that to the state and do nothing if it's a nothing, and then just go on. So I can make a nice helper function, like so. Does this compile? It may have some problems with the n. No, it doesn't. Okay. So then we can write mdo like so. Does that work? Voila, that cleans up the whole thing a bit. Now let's check if it works. Okay, so I can go left, right, and I can add text. Good. Let's make a commit so you can follow along if you're typing with me. Okay, so we're now a bit more than halfway through the time. Let's take a break here, have some water, coffee, sandwiches, and then continue afterwards, okay? So I talked to a few people in the break. Apparently I talk too fast and I type too fast, so I'm going to try out talking and typing a bit slower. You will get the most out of this if you can follow along. So if anything prevents you from following along, feel free to shout it in the case, speak slower, type slower, speak clearer, for example, or explain a piece of code. I will do it, but you have to ask. Okay? So let's take stock. We have got a nice application that can open a text file and you can move left and right and enter characters in where you're looking. The next steps are going to be to move around up and down, delete stuff, and also enter new lines. Okay? And after that we can add whichever feature you want to see after that. Okay? Any questions up till now? No? Okay, so let's do this then. To move up and down, we'll use key up. And there is select previous line for that. So that's rather easy to fill in. Key down is select next line. And I forgot my feedback loop. There we go. So I just copy pasted these two functions from the documentation. And you can fill them in with the mdo stuff. Now if I launch the application again, I can move up and down in the file. And if I add text here, it will go there, etc. So one thing you might notice is that if you're at the end of the line on a longer line and you then go to the previous line, you go to the end. But if you now go down, you're in the middle again. So that's a potential problem that I'm not going to fix because it would involve rewriting the entire text field cursor. You need to somehow make a distinction between I am at a position which is at the end of a line and I am at the end of a line to make that distinction. So if you want to do that, that's a nice exercise in writing your own cursor. I don't find it interesting to solve at this point.
It would require an additional state inside the cursor.
Exactly. You would need an extra state. The other problem is that if you have a really long line or a really big font, you can type off screen. There's no nice way to fix that unless you can forget about the blinky box. Because the reason that this doesn't wrap, it could, but if it would wrap, then the location of the blinky box would no longer be a simple XY coordinate, because you'd have to add an extra point to the Y coordinate for every line that's being wrapped. So I also didn't solve that problem. Okay, so we can now go up and down, and then I'm going to try 2 more things before I commit again so you can follow along again. First one is key backspace, I think like this. And now it's going to be something different than mdo, but I want to be able to remove a character, not delete it. So that means remove the character before the cursor instead of removing the one afterwards. So there should be remove right here. And if I just write mdo with this, then I will get a big compile error. Exactly, because it expects a maybe text field cursor, but it has a maybe of delete or update. So first I'm going to show you the delete or update type. It's a fancy maybe, okay? So the reason why you might want to use this is because if your file is empty and you press remove or delete again, then maybe you want your entire file to be deleted instead of just having nothing in your file. So that's why there is this option for you to do something with it. But there's also this thing here, dull delete, which turns one of those maybes into a regular maybe. Okay, that's when you don't care about removing the file, for example. So, I just add dull delete in front of it, and I need to import cursor.types to get it. Does that work? Yeah. And then I want the same thing for the delete button instead of the backspace button. So there's key del, I think. And now it should be able to remove and delete items. So now if I install it again and I run it again, I can now delete stuff, backspace and also delete. And if it's at the end of a line, the text field cursor automatically takes care of putting the 2 lines back together. So that's nice. Now we can't have any more lines than the 1 line that I'm looking at because there is no way to insert a new line because a new line is not considered a character. Instead, when you want to have a new line, we want to do that with the enter button. So let's implement a handler for the enter button. I think it's key enter. And there is a function in the text field cursor, insert new line. You probably want to insert new line and not append new line. Except this creates a text field cursor from a maybe text field cursor. So we can't just use the function mdo. We have to do something a bit more fancy. First of all, we have to pass in just. And then we have to add just at the end as well. I think that's it. Alright, so what this does is it wraps the text field cursor in the state in just to pass it to the function, which will give you a text field cursor, but we want a maybe text field cursor, so I'm wrapping it in a just again. Alright, so now if I run this, I should be able to press enter in the middle of a line and have 2 lines.
Wow.
This looks so anticlimactic if you see it like this, but I found this amazing the first time I saw this. So let me commit this part. Good. So now we have a quote-unquote fully functioning text editor. From here on, it's really up to you what other kind of pieces you'd like to add or change. If you have some of your own ideas, I invite you to go ahead and try it. Otherwise, I'm just going to pick out bits and pieces of extra functionality that we could have and see if I can implement them. The pieces I have in mind are getting rid of this, so that you can edit any file instead of just this example file. And then I also want to be able to save the file after editing it, because otherwise it's pretty silly. And then maybe we can do some fancy styling. and then maybe some nice border. Does anyone else have any other ideas? Undo. Yes, let's do that. We can do that.
And go to the next line with cursor at the end of the line. If you press right, it doesn't go to the next line.
Yes. We can also do that. Let me write those down. Implement undo. That's actually easier than you think it is. It's not efficient, but that is a separate story.
Store list of states in bold step?
Yes, except it's a stack. Yeah. So implement undo and pause. Go to next line if at end of line and press right. Any more ideas? No? Okay. So let's do some copy paste. That's significantly more difficult because there is no way of remembering the selection. I can't think of a way to do that without having pointers into your text.
At least when you duplicate the line.
Duplicate a line, yeah.
You can remember this cursor position, but copy paste the things style. Remember the cursor position at the start, and then move it around, remember second, and then separate key to insert.
But then we will need the states instead of no.
Yeah, and you don't, if you have two text field cursors, it's not obvious that they represent the same text, but just looking at a different place.
You'll have to handle it with events in the application separately, right?
Yeah, you need to somehow remember where you were looking before and after, and if you're going to do that, I don't think there's a way to do it without remembering locations separately from the cursor, which is not ideal. So I'll write it down, but I don't think we'll get to it. Copy, paste. Anything else?
Can we replace mode?
Replace
When you
mode.
type something and it replaces text?
To end of the word. I'll also add end of line. Anything else?
Uppercase button.
Uppercase mode. Is that what you said?
Uppercase current word.
Ah. Current character or word?
The word.
So text field cursors don't know anything about words, so we'll see how that works. Anything else? Okay, so let's start with the easier ones first, and then we'll work our way up. Let me check if I...
And maybe just get rid of the half of the...
Half of the?
Half of the items on the list. Get rid of them.
No.
Start with that.
We'll see how far we can go. So this is only the to-dos. Okay, so there is a... We can do some niceties, like adding a border around our widget. And it's from brick dot... What the hell? Oh, it's a fan. I thought it was the projector. Brick widgets border.
This comes with your really serious on borders, so.
So now we have a border around the text itself, and also the extra line at the end. Voilà. So now we have a nice border. Okay. The problem is that the border is around the text instead of around the entire terminal. So it's up to you to figure out how to do that if that's what you want. Sorry, it's up to you to implement that, but I can tell you how to do it if I remember. So every widget in Brick has their own policy about how to take up space. So there is either the strict policy, which says use as little space as you need, and then there is the greedy policy, which means use as much space as you want. And then you can also make your widgets bigger by adding spaces if you want it to be anything in between. So I'm not going to do that part because I would have to look it up, but it is possible. So we can have a border, and now the other thing I want to do is to have my text editor in the middle of the file instead of at the top left. Sorry, the middle of the screen instead of at the top left. So the way you do that is with center layer, like so. And it's in widgets.layer. No, it's wrong. Hold on. I will, widgets.center, sorry. Voila. So now the text editor is in the middle. Cool. You notice that we have the blinky boxes on the border, which is a bit strange, you could say. So I will try to add some padding around the inside of the border. And you can do that with pad all one for one character. Like so. And now there's padding on all sides. Right? You can pad left, right, like so, and then you don't have padding at the top and at the bottom. Oops. Like so. Now you don't have padding at the top and at the bottom. This is quite nice, I think. You can also just only pad on the right side, for example, or you can do pad right max. And now it will put as much space as possible to the right. Like so. Note that if there is much more stuff to the right, that pushes the entire thing to the left if it's centered. So that's why that happens. So let's just pad left, right. The other thing I want is to have a nicer color than this, let's say white. So the way you do that is you give it an attribute, and then you give the attribute a style. So we can say with attribute text, for example, you just give the attribute a name, and then in the attrimap, you have to say text will be foreground red. And I need to import that from where? FG is from util, I think. Yes. No. And red is from somewhere. Not in this library, it seems. So I need to get that right out of the VTY package, I think. Yep, so I need to import this thing and then import VTY. I already have VTY. Oh. Not color. And now it should all be red, including the border. Like so. Or not including the border, apparently. Because there is still this little bug in the brick library that colors some of the border depending on where you're coloring something. But I think I figured out a way to make that go away. Yeah, there we go. So now we have a red text editor. Nice. So those are the little niceties. The other things I might want is, for example, do my border in a different style. You can really go far with this. So you can use different characters for the border. So here, border elem, where you can say, give each of these different pieces of the border. So you have all the sides pieces, the top pieces, and all the corner pieces separately. And then you also have the connection characters for if there is a border that connects like a T or like whatever that character is. So you can really go far with this. And then there's also, now I really want to try have the background, so the thing around the border be, instead of empty, have it be something so I can show you the different layering. And I think it's called fill. Yep. So now, the first element is the top layer, I think. So now if I do fill at, for example, it should fill the back of the editor with at signs. See if that works. Ta-da. Wow. That's really silly. What if I do this? not any better, is it? So there seems to be some sort of trouble. Maybe I have to do it inside the padding. Yeah, so I don't know how that works. I've complained about this before, but there doesn't seem to be any solution just yet.
You know, this is great. I feel myself like in the browser. It's like at home. Yeah, I love CSS. You know, it's,
Do you remember Young Cat?
So maybe we can actually color every line in a different color and then it will be a rainbow. Let's not do that just yet.
and maybe reset it all at the end of the line.
Yeah, the thing is that there is no such thing as a reset color in
Yeah, I see. It's
the primitive, but there is such a thing as what we could do, I think, is give the background as a separate attribute. And then like make it really flashy. Like so. Yes. All right.
And what's the point?
Fancy editing.
What was the key to fixing this?
The key to fixing it.
To use default attributes. So they are not depend.
Yes, exactly. So there is such a thing as the default attribute, which is going to be used if you didn't give any attribute by yourself. And I think if you just make sure that the thing that's going wrong doesn't have the default attribute, but rather something else, then it will color that right, I think. But I'm not sure. I'm not really sure on how that works in the background, so no clue. Okay, so we have some fancy editor with blue and red. Next step, I'll say we'll edit a file of a certain argument instead of any file. Yes? Okay, thanks. Cool, so now let's see if we can edit any file in particular. There is a function called getArgs, which gets you the arguments that you give to the file, to the executable that you're running, and that's in system environment. You will get these args here. This args is a list of string. So what I'd like to do is to report that there is no file to edit if you didn't give an argument, and then if there is such an argument, use it to build the initial state with. So I want to say, look at the different cases of this list of strings. If it's empty, die, no file to edit. Or rather, argument to choose file to edit. And then if there is an element in the list, that means there is a first element and a bunch of other elements that we won't care about. And then if there is such a file path as the argument, then I'm going to give it to build initial state, which will now need an argument. And that's what we're going to pass into resolve file. So. And die is in system.exit. So if I run this now, it should crash. Yes, exactly. And now if I write example, we can edit the example file. The next thing is that it still doesn't save that. So instead of printing the end state, I want to turn the end state back into the contents of a file and then write it to the file. But also I want to make sure that the file is only saved if it was changed, because otherwise you're going to mess with the modification dates. So to turn the end state back into a file, we need to figure out what the contents are. So state cursor will contain the cursor at the end. And then I can use rebuild text file cursor to turn that back into a text. And then I can t.write file fp contents. And that should do what we want. If this doesn't do what you want, it's because we shouldn't be using t.write file because of encoding issues, but it should be fine for now in this example. Rebuild text file cursor. What did I do wrong? I can't see the... Sorry? Ah, yes. There we go. So now the only problem with this is that if you don't want to save the file, there's nothing you can do about that. So now I can move this silly new line at the end, close it. When I open it again, it's not there anymore. Yes. So the file saving works now as well. And now I want to make sure that if you save a file, but the file hasn't actually changed, then there's no point in writing to that file again. The way I'm going to do that is instead of passing in the initial the file path into the initial state, we're going to pass in the initial contents. Like so. And make the contents beforehand. And now I want to check that unless contents equals contents prime, so the new one, we want to write. And now text needs to be imported as well. Like so. Now unless is in control of monad. Yep, okay. I made a silly mistake somewhere. This now needs to take the contents instead of the file name. Okie doke. So now if I make no change, it shouldn't save, but you can't tell. And if I do make a change, it should save. Yes, it did. Okay, great. So that's that part. The reason why you want that is if you look at the modification date of example, you don't want it to change if you didn't modify anything, ideally. You know, this kind of went out of the window with Dropbox, but it's still nice if you think about this with your own applications. So let me commit that and push it again. How much time do I have left? It's now 7, right? 7:05? How much time do we? Sorry? Okay. Oh, right. So hold on. Load and save specific file. So I have 15 more minutes. Is that right? Okay. Good. So we can continue along this list. Or if anyone has any other ideas of things to implement, feel free to shout. And then yes, tell me.
As far as I can see, our case is going to be big, right? So now, like, how are we going to scale it? I mean, the list of variants.
Yeah, this one you mean, right?
Yep.
So there are a few problems that you can solve simultaneously. So this is one of the problems that your code becomes rather unmanageable. The other problem that you may want to solve is that you may want to be able to rebind your keys, and you can't do that in this case. So you'd have to sort of get the configuration of your key bindings out of a file and then put it in there correctly, and then run the appropriate functions. So you can solve both of these problems together by creating something like a key map that has the mappings that you want, that you can load from a file, and then have this case matching operate on a key map which has a list of bindings, for example. So Smoss does that, for example. Let me give you an example of Smoss. Smoss has a bunch of key bindings, bunch more key bindings. Smoss is also a TUI, it's also an editor, but it's not a text editor. And it has its own self-documenting help screen that you're looking at right now. Oops. And when you rebind these keys, the help screen will also show you the right keys that have been bound. Now, in this situation, the current context of looking at an empty file, these are the things that you can run. So for example, if I press E, it will start a header. And so indeed, if I press E, it will start a header, right? So the way that happens is, it's going to be a bit bigger to look at. You can configure SMOS like this. So you can say in every context, this is the binding that I want for that piece. And then you can load rebindings from a file, for example. And this file key map, or rather this key map, is then what the event handling function will operate on. So if we look at the event handling function, it's a bit more complex, of course, because there is a lot of stuff that goes along with this. Here, the key map function takes a state, an event, a key map, and gives you the result. This involves also taking care of more complex activations, like multi-key activations. For example, if you write FF, then you may want to do something else, or GG to go to the top of a file. The problem with that is if you press AGG, do you want this to still happen? Or if you have a key binding for both G and AG, which one you want to activate, etc., etc. So there's a lot of complexity in there in the code that I'm showing you right now. If you just want single file binding, single key bindings, it's a bit easier, but you can use the same approach.
Yeah, but without the function, if we just gonna write like static way to how can we like list of options?
Yeah.
I just very often encounter this problem. How to split them?
So the way I think you can do it is have something like binding equals binding key, and then text field cursor to maybe text field cursor, something like that. And then you have bindings equals a list of binding, and then you can have this this matcher here, a little bit different, where you can say, let's put this in comments for a moment. I'm just going to show you how I would do it. I won't do it in practice because this is going to be a bit messy. If you have a VTY event that is a key with now mods, then you can do find binding key func if key equals key prime, then just then true, or let's just do it like this. And then you will get a maybe binding. From that binding, you can then execute the function. So you can separate those two. See what I mean? So that's a way to do it. And then the nice thing about that is that you can get these rebindable keys for free. Any other questions or proposals? No. Now I can go on implementing pieces of a little fancy colorful editor for the rest of the evening. So if that's what you'd like to see, then I will go on. Otherwise we can also stop early. What do you think?
Tell us a little bit about SMOS, why you chose to write it, why you chose Haskell.
Alright, so I can talk about SMOS. Anything else?
Could you please repeat the questions when they are asked?
Oh yes, okay, I will. So the question was, if I understand, if I could tell you about SMOS and why I chose to write SMOS and how. Any other questions or proposals? Okay, so I will tell you a little bit about SMOS and then I will go on with some of the implementation if you'd like. So, do you know what getting things done is? Right, so do you know what org mode is? Alright, so org mode is very interesting, even though it has a bunch of bugs, but it has the whole Emacs thing around it, and that part I don't like. So I like org mode, I don't like Emacs, so SMOS is essentially org mode without the Emacs. Except it's optimized for getting things done. So this is going to just be a little demo of SMOS then. In SMOS, you have this is a forest editor, so you can have entries in your forest, and entries have a header. So this is a header. These are contents. This is other entry, and you can then go lower, sibling, even lower. So here you have a forest of things, of entries, and each of these entries can have a to-do state, for example. And each of these entries also remembers the past of their state. So when the state changed, for example. And then each of these entries can also have tags, for example, the home tag or freeform tags, online, offline. You can configure these for yourself. It can also have clock. So here's a clock. It will start to run a clock for you. And then these clocks are, there is only one clock that can be open at any time across all of your files. So if I start a clock somewhere else, it will close the previous one. I already said there are contents. There are also properties. So I can say this is going to take me 2 hours, for example, or rather it's going to take me 2 hours to get started. I think that's all of it. If you don't know what to do, by the way, you can just look around in the help pages. Oh, right, timestamps. So if I want to say I want to do this on a specific date, I can schedule it for example, tomorrow at 11, and it will figure out when that is, and you can select your timestamp like that. Timestamps also work on a date base, so you can say the next 29th of February, which will be next month, for example. But if it was in 2 months, for example, it would be 2024, February 29th, for example. It will figure that out. So that's the editor itself. Now, why is this useful, you may ask? It's because if you can schedule your getting things done stuff in there, you have really nice reports. So there's Smoss Query. I'm not going to show you all of this because this is my personal life, and this is going to end up on the internet. But Smoss Query lets you, for example, list all the things you're waiting for someone else for, or all the next actions in your stuff. The current clocking, where you spend time, your agenda, timestamps-wise, a list of your projects, etc., etc. So this really allows you to compose your own GTD system.
Smoss Query just prints it on a terminal, not in a 2D format.
Correct. There is also an interactive report that I won't show you because it's personal info, but it allows you to scroll through and then go into the files, for example. So that's the idea. This is also where the whole brick cursor and cursor brick libraries came from. Sorry, I didn't make brick, but I used brick for Smoss. And this is why I'm interested in it, and also why I'm talking to you about it here. I think I have every part of your question now, right?
How many users do you think use Smoss?
2. No, I have no idea, to be honest. I know that there are some people at my coworkers that use it, but honestly not so many, and there are already not a lot of org mode users. So. But that's really not something I care much about because I made it for myself. But if you're interested in using this, come say hi afterwards and I'll set it up for you. So that's the Smoss background. So I used Brick to do this because I wanted to do it in Haskell. I wanted to see what an editor in Haskell would look like. I also have a blog post series where you... what? Okay, no, not touch it. So I also have a blog post series. Nope, bad idea. Is it? Damn it. Oh, okay. Where I go through cursors from scratch. So for example, it starts with the list cursor, how it works, how you would write one, why this is the way it works. There is an overview of all of Smoss. So you really have each of the cursors, and then also building up to it, different editors. So it starts with a single line editor, then there is a simple text editor, that's what we did today. Then there is a tree editor and a forest editor, and from there on you basically have seen all of the cursor work in Smoss. This was to encourage contributions. Not that that happened, but now this information is out there if you're interested in this sort of stuff. I've been using it for more than 2 years. Oh, clock. So the cursor library itself, I'm showing you this. I don't have clock, do I? Okay, hold on. Yay, NixOS. So there are about 6,000 lines of cursors. And 20,000 lines of smalls. I know for a fact that this would be a lot more if it wasn't Haskell, because Haskell is quite concise in these kind of things. The cursors are a lot of boilerplate though, so it's quite big. This is the state of development. So you have the smalls editor, you have the querying, and then there are a whole bunch of other things. Like for example, there is a Dropbox-like client, such that you can synchronize your smalls files across devices, which is where the cooperative agreement talks that I did came from. So there is this library called merge-less, and there's also merge-full, which allows you to have multiple devices that agree on a set of values.
So the syntax of that small files are not compatible with Java, right?
Correct. The smalls files are just YAML. So if you look at a smalls file, it looks like this. So they're just YAML files, which I did on purpose so that it's really easy to make your own tooling around it. So it's not just text. That's another reason why I stopped using Oracle, because it's all text and it's in an ambiguous grammar. So
If you have to query with JQ,
yes, but okay. So let me see if I can show you a little bit of it anyway, but then with this custom. Now if I do smalls workflow dir equals this. Okay, perfect. So now if I show example here, so let's say I have some actions in here. I have something scheduled for tomorrow, a deadline in 3 days. I have something online, something with toast. Toast is just for things that you can do when your brain is toast. So now if I do smalls query entry, which is just like some SQL query, you get it like this. Having this show up with JQ is a bit difficult, right? And then the even more difficult part is where you can compose your own reports by saying which columns you want. And then you can say, give me everything that I'm waiting for. And it'll show you how long you've been waiting for it. Then give me all my next actions, my agenda. The agenda is split into past, present, future, and like you can do this with JQ, but I'd rather not. And also you can have, for example, filters on the entries. So I can say, give me everything that's in the file example, or give me everything which has a parent of which the state is next. So it can also have filters based on the location of an entry within the rest of the file. It's quite comprehensive at this point. It goes quite far, but this is not what you came here for, so let me finish answering your question there. Any other questions? Is there anything else you'd like to see happen in the text editor before we end it? I mean, I can go on with the to-dos, but it depends on whether you'd like to say.
Reference for building that query language is to build by your own.
The reference for the query language, yes, I built it myself, but you can read more about it on the documentation side. So here is an explanation of this query language. So this took a bit of tweaking to get right, because, for example, some parts, like after property, you have to have a property name and then a property value. Parsing this correctly is non-trivial.
Parsing the smalls file would probably create some data structure when you're telling smalls in memory. So
Yeah. Let me show you. So you have the regular cursors in the cursor library, but then you also have specific smalls cursors.
So there is a conversion between your data structure of the data to the cursor tree.
Correct. So So in SMOS data, there is the definition of the data structure that you see in the file. So here, a SMOS file is a forest of entries. An entry contains a header, contents, yada yada, right? And then there is a corresponding entry cursor, which is a bit of the wrong thing to show you maybe, but it contains cursors recursively of what is inside the entry, and then also this selection, which tells you which part of the entry you're looking at. So you could be looking at the timestamps, or at the header, or at the contents.
Each part is written in.
Yes, exactly. And so cursors need to be nestable, because within a file you're looking at a forest, within the forest you're looking at a tree, within the tree you're looking at the entry, within the entry you're looking at the header, within the header you're looking between two characters.
So wait, you probably know one cursor and the rest of the string can be just that?
Yes, exactly. So that's why there are two type parameters for cursors, in particular for a forest, for example. Let me show you that too. So here, a forest cursor has two parameters. The first one is the value, the type of the value that you're looking at, and the second one is the type of the other values. So if you have a forest cursor of entry cursor entry, that means the currently selected element is an entry cursor, and the other elements are just entries.
Why the parameter matters?
Why, what, sorry?
Why the second parameter matters?
Because otherwise you would have to have an entry cursor for every entry in your file, and you can do that. I have done it. The problem with that is if you're looking at, for example, the timestamps of one entry, and then you go up and you look at the header, and then you go back down again, you will be looking at the timestamps again instead of at the header. So you could work around that, but that's just extra information that you don't really need. It's the same thing with the text file cursor. So if you have a text file cursor is a non-empty list cursor, which also has two parameters. The first one is the type of the thing that you're looking at, and the second one is the type of the other things. So in a text file cursor is just a non-empty list cursor of text cursor and text.
Whenever you enter in the edit mode, the type of the first type from changes to the data structure, when you live in it, the A becomes B.
Yeah, exactly. And so when you move around in a non-empty list cursor with this kind of more general type, you have to pass in the functions of going from A to B and B to A so that you can go to the right one. There is also a simpler list cursor interface if you have only one parameter, like so. And in that case, all these parameters are ID. Make sense? So there has been a lot of work in making something like this happen and then manipulating the entry cursor. So if you're looking at the actual state of a SMOS file, I can do that with Alt, Shift, Enter. This is the actual state. So there is an editor cursor, which shows that there is nothing in the file, there is no report, there is no help. So now if I open an entry, suddenly there is a bunch of stuff. So you can see a file has been selected. Within the file there is a forest, within that there is a tree, within that there is an entry, within that there is a header, within that there is a text cursor, and etc. etc. So with some nice lenses you can edit the appropriate piece. So that's how that works.
Seems like a lot of work.
Yes, it was. But I am very interested to hear if in an easier solution if you have one. Because I haven't found one.
Just use org mode.
Yeah, just use org mode. I had been switching between org mode and task warrior for years. Like every half a year I would use task warrior because it was command line and I could automate stuff. And then I would go back to org mode because I would want to have more nodes, and then I would switch back again. And at some point I just said, I'm tired of this and I built this.
And then using this on your phone?
I recommend against that. And the reason is I use my phone only to capture ideas and never to process them. So there's a separate tool for that. It's called Intray. And this does work on a phone and has an app. And Intray is super simple. Yeah. It's not stolen, reused, I would say. So you just add your items here, this works on a phone, and then you get them in a list where you can only see one of them at a time so that you're forced to process them one by one. This also synchronizes with my local device here. So I have Intray size, so there are 10 things in my Intray at the moment, and they synchronize automatically between the web server, my phone, and my computer here. And you can actually get it to show up in your prompt such that there is a nice one here if there is one thing in your Intray, for example. I haven't done that right now because I just set up a new operating system and haven't. Oh wait, I can maybe show you that if I SSH into. So now I'm SSHing into my AWS server, which is then going back through a reverse SSH tunnel to my house. And then I'm going to another machine in my house. Voila. So now you can see.
Nice name, though.
Nice what, sorry?
Names of the server.
Oh yeah, I named them in Latin numbers. So here you can see that there are 10 things in my Intray. I can add an 11th one, and it's right there. And then when I do isync, it will be synchronized with the server and then synchronized with my phone as well. So that's why I don't use my phone for org node editing, because I just don't need to. And then there is something similar to this. I'm just talking about my personal workflow. There's something similar to this called Tickler, which is about getting something into your Intray at a later date. So you can do Tickler add 2022-29 weird day. It's the other way around. Voila. And now it will be sent to my Intray on that date. And you can also have it send you emails instead. So you really don't need to open SMOS on your phone, is what I'm trying to say.
What about agenda? You may need it on your phone. Agenda.
Sorry?
Agenda.
Yes, I use Google Calendar for that. The timestamps are only for deadlines in my case. So I do plan on writing something at some point where you can see your SMOS workflow on your phone, but it's just me, so there is no extra manpower or anything.
There is an app for that, for org node.
Yes, I know, and I had a lot of trouble using it because it uses these UUIDs for entries to make sure that they are kept synchronized if you move them across files, and I find that a bit messy. So when I, especially because they're just text files, you can't hide that or something. So when I implemented the synchronization in SMOS, it takes care of that problem in a completely different way, and actually merges separate changes to the same file correctly, for example.
You mean the concurrent changes from several devices?
Exactly. So it's a bit like Google Docs in that sense, that you can have two people editing the same thing. It's different in the fact that you can have an arbitrary amount of offline time in between synchronizations instead of where it has to be online. So you can use also an airplane and then synchronize when you land, for example.
How do you decide which change is more accurate if you change the same thing?
So if there is a conflict, the first one that gets to the server wins at the moment. I don't intend for that to stay. The intention is that when there is a conflict, that it automatically creates a conflicting file and a to-do in your to-do list that says, go fix this conflict. But that's not implemented at the moment.
You can use some fancy data structures like CRDTs.
Yes, so there is a CRDT for YAML, except it still has to deal with conflicts. So you can't actually have an entirely perfect CRDT, which is associative, commutative, and because if someone edits the same character in the same place, there is no way to really know which one is supposed to come first unless you have something like that. There are some data structures in which you don't have this problem, but not YAML, sadly. I looked into that paper though, it's interesting. Yeah, there is a way to do that. I like this Q&A thing. Any more questions? Otherwise I'm going to end it here.
the second favorite programming language?
Programming language. The second one I use most is Nix, but I don't like it.
Nobody likes it.
No.
And what's wrong with it?
But it's just the language is not as bad as I make it out to be, but the tooling around it makes working with it a bit tedious. For example, at some point it's not typed, for example, so if you in certain situations, if you enter an expression instead of a file, you'll get an infinite loop and you don't know why. And it's just unnecessary complexity that I don't need there. Then other languages, I mostly don't use many other languages anymore, so mostly yes. I just don't like anything else at the moment. I would like Rust if ever I had a use case for it, but I've never had a use case for it, so I don't know. It's the same with machine learning. I mean, I've studied machine learning, but I've never needed to use it, so I just don't do. All right. Any more questions? Nope. Okay. Thank you all for coming. It was lovely.